Hey you guys, so I wanted to make this video just to kind of wrap up what we did today. I know it's a little different for you guys to just start with a problem and play around with it and use the knowledge that you have, or algebra knowledge, to try to come up with an answer. And I appreciate those of you guys that were resilient, you made mistakes, you corrected mistakes, and you kept plugging away at it. So what I want to do in this video is I want to go over three methods that I saw you guys using. There are actually more than three methods, but here are the three most commonly used when solving these rational expression equations. With each method, I've written out to the left kind of the steps that you go through, and then I'm going to apply those steps to the same problem. So you'll notice I have the same problem for all three. So let's take a look at the first problem here. So here we have three terms. We have one term on this side and two on this side. With method number one, the first thing that you can do is you can combine all the terms to get a proportion. So a proportion is when you just have one term on both sides. So since I have one term on this side, it means that I want to get this expression into one term. Because these two terms are being added, and they're technically fractions, we have to have a common denominator. So looking at this denominator is 1, I'd see that my common denominator would be x squared plus x. So if I wrote out this denominator as x squared plus x, and this guy is going to stay x squared plus x. I looked from the old to the new and I asked myself, what do I have to multiply the tops by? Or what did I multiply top and bottom by? In this case, they're identical, so the top just stays the same for this guy. Here I had to multiply the bottom by x squared plus x, because that would make that x squared plus x, and I have to multiply the top by x squared plus x. So for right now I'm going to write it like this. And this side I'm just going to keep as 1 over x. So let's go ahead. On the right hand side, I now have common denominators, so I can write this as a single expression with my common denominator, and that means that I need to combine my numerators. This particular expression is going to be 5x squared plus 5x, and then if I add in 1, none of those are like terms, so the top just becomes a 3-term quadratic. So there's 5x squared plus 5x, and then plus this 1. Now I have what we call a proportion, one fraction set equal to another. The second step is to cross multiply. So this is when I spell it like this because you want to look diagonally, and you multiply this denominator with this numerator. So if I did that, I'd have to multiply x by all three of these. So I would get 5x cubed plus 5x squared plus x times 1 is just x. And then you set that equal to the other cross product. So you multiply this direction diagonally. So anything times 1 is just itself. All right. Next step, it just says solve for the variables. So see, we see here we have a lot of terms. It'd be nice if we could get some of the like terms together. I see that this is not a linear equation, so I'm probably going to have to factor in some sort or at some point. So I'm going to get everything set equal to 0. So I'm going to subtract x squared from both sides. So that would make this 4x squared. And I'm going to subtract x from both sides, so that x is going to go away. And there I'm left with a cubic, so I'm going to see if I can factor this. I can take an x squared out of both sides. So it'll leave me with 5x plus 4. And now I can set my factors equal to 0. So if I set this equal to 0, I'd get x equals 0. And if I set this equal to 0, I'd get x equals negative 4/5. Now in this particular case, I know right away that this can't be an answer because if I plugged in 0, it would make this term undefined. So therefore, sometimes when you get an answer and it doesn't work out, or it makes your expression undefined, it's called an extraneous solution. It's like an extra solution you get by solving, but it actually ends up not being a solution. It's kind of annoying. And I'm going to hold off. Usually what I would do is I'd plug in negative 4/5 there, and there, and then I'd simplify both sides to get an actual number. So I know that this side's going to be negative 5/4. And see if I can get both sides to equal the same number to guarantee that this is a solution. For us to double check, I'm going to solve this same problem two different ways. If we get the same answer every time, we're going to assume that this is a correct answer. So all right, method number 2. Method number 2 is a little bit different. You try to get a common denominator for all the terms. So in this case, if I start off and I look at, to get a common denominator, I have to factor. So I'm going to first factor this guy. I can take out an x, and I'd have x plus 1. So if we use what we did the other day, my common denominator has to include all my factors in any of my expressions. So the only factor of this one's x, so I have to have an x. This factor's 1, so that guy's just 1. And this guy has 2 factors. One is x and one is x plus 1. Because we already have 1x and this guy only has 1x as a factor, we only have to put 1x in the common denominator. But we also have to include this x plus 1. Alright, so there's our common denominator. So I'm going to write all 3 expressions now with this common denominator, x times x plus 1. And then start to compare. So the first fraction they have the same denominator, so the top stays the same. For this fraction, I have to multiply the top and the bottom by x times x plus 1, since this guy has none of these factors. So this would be 5 times x plus 1. And this guy is only missing a factor of x plus 1, so I can multiply this times x plus 1. Now that we still have 3 terms, but what we can do now is, because these 2 are being added and I have common denominators, I can combine my terms to get a proportion, so kind of like the last one. So in this case, I'm going to go ahead and combine my terms, so this side just stays, because it's just one expression. And this side, the common denominator, and on the top, if I multiply this out, I'd get 5x squared plus 5x, and then I have this plus 1. And in this case, why this one is different now is because we have common denominators in this proportion. Up here we didn't have common denominators. So the nice thing is, if you have a proportion with common denominators, that means that this divided by this denominator equals this divided by this denominator. Since the denominators are the same, for these 2 fractions to be equal, the tops have to be the same. So what you can almost do, it's not really like you're canceling them out, but you can totally ignore the denominators if they're the same and just set the numerators equal to each other. So we have x plus 1 equals 5x squared plus 5x plus 1. Again, I have a quadratic, so I'm going to set everything equal to 0, so I'm going to subtract. I'm going to get 0 on this side since I'm just going to subtract these guys. So I'm going to have 5x squared, take away x from both sides will leave me with 4x. Take away 1 leaves me with 0 on that side. So here I can factor this. I can take away an x, set those factors equal to 0. So we get, sorry, I'll zoom in, x equals 0, which again was one we got last time, but it was extraneous. If I set this equal to 0, I'd have to subtract 4 and divide by 5. So sure enough, you guys, we get the same 2 answers. In this case, this one obviously is extraneous because we can't plug in 0. That would make this denominator 0, which would not be good. So this guy is an extraneous solution. Right now, I'm thinking -4/5 is our correct answer. We'll do it one more time a different way. Hopefully we'll get the same thing. For your homework tonight, you don't have to do it all 3 ways. By all means, find a way that works for you. But then you do have to go back and prove to me when you plug in your solution that you get both sides of the equal sign to equal the same thing. All right, last method. All right, method number 3 says get all terms on one side. So just bring everything over to one side. In this case, I'm going to bring this term over since I only have one term over here. So this would leave me with 0. On this side, I'm going to write this as 5/1 just to kind of get ready. I'm anticipating I'm going to have to get some common denominators here. And then subtracting the 1/x. All right, so in this case, next step says using the laws of fractions, or just algebra, combine all the terms into one rational expression. So get all these 3 and combine it into one fraction. So that means that we have to find a common denominator. We already know what our common denominator is because we talked about it on the last problem. So it's x times x plus 1. If I factor this, this would be x times x plus 1. So we know this guy stays the same. This guy, I have to multiply the whole thing by both of these. So this would be 5 times x plus 1. 5 times x plus 1. This guy is only missing a factor of x plus 1. So now we can actually combine all of them. This is where it gets a little tricky, especially if there's subtraction. So my denominator is just this guy. On the top, I'm going to maybe take a couple steps to do this. I'm going to have 5x times x is 5x squared. 5x times 1 is just 5x. Then we have this plus 1. And then here with subtraction is where you have to be really careful. In this case, we're subtracting this whole numerator, which essentially means that we're subtracting x and we're subtracting 1. So it's like you have to distribute that minus sign through to both terms. So I'm just going to write that as minus x and minus 1. Now, let me simplify. I know I can put some things together. So 5x squared, that's the only guy. I know I can combine the 5x and the negative 4x, or the 1x to make 4x. And the 1 minus the 1 goes away. Now, you guys, because we have a fraction set equal to 0, the only time a fraction can be equal to 0 is if the top is equal to 0. So since we have just one fraction set equal to 0, now you can just set your numerator equal to 0 and solve for x. So I'm going to kind of take this problem over. I'm just going to move it right over here. So for this fraction to equal 0, I know that the top, which is 5x squared plus 4x, has to equal 0. This is a quadratic. I can factor, take out an x. By now we're kind of tired of seeing this. We see that x equals 0 and x equals negative 4/5. So a third strategy, we know this can't be an answer. Same solution every single time, you guys. Again, I'll put this here so you can pause your screen and write any of these down. Pick a method that works for you. You don't have to know, I don't know if I can zoom out enough. You don't have to know all three of these. I just want you guys to find one that you're comfortable with and just apply that method with the problems that you're doing tonight. So if you have any trouble, come in, get help. These are definitely challenging problems. I recognize they're challenging. So don't feel like it should be easy. And if it's not easy, that you're dumb or you're doing something wrong. I just really appreciate those of you guys who persevere and recognize, hey, this is challenging, but I know I'm capable of doing this. So anyhow, enough of the pep talk. I will see you guys tomorrow.